In this video, we're going to start taking a look at being able to work with functions in two variables. And one of the most basic sorts of things that we have to do with a function of two variables is to be able to plot that function, but then also to take a look at perhaps the level curves of that function. And of course, the graph of function can help us be able to determine the domain as well as the range of that function. I'm illustrating two different ways to be able to graph a function in two variables in this video. One of which is by using the vector method, all right, and that's where we're going to just create a mesh grid, assign it to an array, and then we're just going to go ahead and plot it using the surf function. All right, so this works really nicely. I found that this works pretty nicely if x and y have the same domain. So for instance, if x is from -2 to 2 and y is from -2 to 2. So if that's not the case, then it might be easier to use the easy surf command. And I know MATLAB doesn't necessarily like the easy surf command. I do like the easy surf command, and it works pretty well. And easy surf command takes advantage of the symbolic variables. All right, so what we're going to do is we're going to define symbolic variables for x, y, and f, and then we're going to define the function. Now notice up here with the vector function, we have to use a period square. Down here with the symbolic function, we don't need that period because we're not performing those sort of vector operations. And we just plot the function over the given domain, -2 to 2 for x, -2 to 2 for y. We can also have the MATLAB be able to just pick a domain for us, and we don't even have to put in this second parameter of the domain for x and y. So let me show you, I'm just going to use both methods for this first function. And then for the second function, I'm just going to go ahead and just use the easy plot or the easy surf function. So I'm going to start by, let's just go ahead and use method 1, which is going to be the vector plot or the mesh grid. And I'm just commenting so that way when you go back and look at it, you can. So I'm going to define x and y to be an array of a mesh grid from -4 colon 0.2 to 4. And 0.2 is just the increments. All right, we could certainly make smaller increments and it will work out pretty nicely. And I picked -4 to 4 because that's what our function is given the domain of. All right. And then what I'm going to do is I'm just going to define f to be the function, or I could just say z if I wanted to, but I could say f is going to be the function square root of x square, and we're going to say x dot square plus y dot square because it is a vector function. And then I'm going to generate the surface x, y, z. And then I'm just going to go ahead and plot this. It might take a moment. I did forget to suppress the mesh grid, but then here we go. All right, we get our grid, our plot, and what we can do is we can actually turn it around by just holding in our mouse. All right, so in fact, this is just going to be a cone for us, right? Now, and I would suppress this. I just forgot to suppress it, and if I executed it, it would get rid of all of those commands because I have the CLC up here. So yeah, here we have a really nice cone. Now let's use the easy plot function, okay, or the easy surf in this case. All right, and so I'm going to define symbolic variables x, y, and f. I'm going to define f to be the square root of x squared plus y squared. Again, I don't need the periods in there because I'm just going through and defining it as a symbolic variable. And I'm just going to say easy surf of f. And our domain was from -4 to +4 for x, and then from -4 to +4 for y. All right, and let's give this an execute. I'm going to comment this out as well. All right, and there we go. We get pretty much the same graph. All right, this one I think used a little bit smaller increments instead of 0.2. So pretty cool that we can get the graph either way. I know I didn't ask for this, but if I removed the domain and plotted it, it would give us almost the exact same graph. So the default graph is pretty close to the graph defined from -4 to +4 for both x and y. All right. Now, once we have this code for easy surf, it actually makes it pretty easy for us to be able to just change that And so we have this other function, sine x squared plus y squared. So I can just change this to sine x squared plus y squared. And I'm just going to change our domain. It's going to be from negative pi over 2 to pi over 2. And then from negative pi over 2 to pi over 2. And of course, we could use the surf command, but I'm just using the easy surf command just because it's easier for us to do. I'm going to go ahead and run this. Oh, and by the way, the underline says easy surf is not recommended. All right. Personally, I've never had an issue with it before, but. And so here's our function in 2 dimensions. And again, we could grab onto it. We could rotate it to see what's going on underneath the hood. All right, so pretty cool. We could do this sort of thing. Notice that it gives us a bit of a contour map, meaning that it shows us that there's different colors as we go up the as we trace through the z values. So usually it'll default this. There are ways you can change the colors if you really wanted to, but notice that on this horizontal plane right here, that it's all going to be basically like a green sort of color. And then up top here, it's more yellow. So pretty cool that MATLAB is able to do that for us. And then of course, if we look over top like this, then we could kind of get like a contour map, and we can almost see the level curves of this already to be circles, which we're going to see in the next video anyway. So hopefully this video was helpful for you to be able to just basically graph functions in 2 variables. And as I stated before, in the next video, we're going to start taking a look at how do we go through and plot the level curves of these functions in 2 variables.